problem we'll be doing here today is a particle is moving with the given data. Find the position of the particle. Given data we have here is the acceleration at t of the particle, and that is equal to sine of t plus 3 times the cosine of t. We're also given the velocity at time 0 is equal to 2, and the position at time 0 is equal to 0, and that'll be helpful for finding the c's after we do the antiderivatives. So first thing we're going to need to do is find the antiderivative of a at t, which will give us v at t, and v at t is equal to, and in order to find the antiderivatives of trigonomic functions, you're just going backwards as when you're doing derivatives. So normally sine will become cosine, cosine will become negative sine, and negative sine will become negative cosine. But instead we're going to be going the other way because it's an antiderivative. So the first thing, first antiderivative, sine at t will become negative cosine at t, plus, and then we get 3 times sine at t, and plus c, because there's possibly some constant that was there. And then in order to find this c, we can plug in this v at 0 equals 2. So we'll find that now. So v at 0 is equal to negative cosine at 0 plus 3 times the sine at 0 plus c. That equals 2. So negative cosine at 0, that equals negative 1. 3 times sine at 0, which is equal to 0, plus c equals 2. So negative 1 plus 0 plus c equals 2, c equals 3. Move this up here for you. Alright, which gives us that our equation, our general equation, v at t is equal to negative cosine at t plus 3 times the sine at t plus 3, because that was our c value. Then we can find the antiderivative again to get the position at t. So s at t, which is the position at t, is equal to negative sine of t plus, it's going to be minus 3 times negative cosine of, it's already there, cosine of t plus 3t. It's technically 3t over 1, but that doesn't matter, plus c. So that's our antiderivative. And in order to find c, we'll be using our value here, s at 0 equals 0. So we'll plug that in. S of 0 is equal to negative sine at 0 minus 3 times cosine at 0 plus 3 times 0 plus c equals 0. So we get sine at 0 is equal to 0 minus 3 times cosine at 0 equals 1 plus 3 times 0, which is going to be 0 plus c equals 0. So we got 0 minus 3 plus 0 plus c equals 0, which means that c is equal to 3. So our general equation for position at time t, is equal to negative sine at t minus 3 cosine of t plus 3t plus 3. And that's our answer. So using that, we can find the position at any time t of this particle.